How is everyone doing? Oh, come on. Do you have to do the shy thing with the hands and everything? All right, a little more excitement. Okay. So, thank you. Okay, that's much better. So thank you for coming. We were having some technical difficulties here, so I'm going to somebody else's computer, so let's see if we can make this work. So hi, I am Miško Hevery. I'm a CTO at Builder.io. We run a headless visual CMS system. If you want to know about that, talk to me and I'll show you some cool stuff. Anyways, I work on this thing called Quick. Basically, Quick is what we want to make sure that the web is faster, and that's what I want to talk to you about today. I did this thing called AngularJS. You may or may not have heard about it. Thank you. Before that, believe it or not, I was trying to teach people how to do testing, and I had something to do with karma, I think. So what we're going to talk about today? Well, we're going to talk about three things. Basically, that JavaScript, specifically the delivery of it, is the problem. It is not your fault, because it's interesting that a lot of times people tend to blame the developer for the big apps that people create. And then there is a solution to this particular problem. And so what is it that we care about? And what we care about is really this, which is performance, specifically startup performance. And it turns out that this is something that not just us not just we care about, but a lot of different people care about, and specifically Google. Google spends a lot of time and effort trying to make a web a better place because, if the web wins, everybody wins. Everybody's going to have a better experience and so on and so forth. And so Google cares so much that they created this thing called Core Web Vitals or page speed. And basically what they're saying is, look, we know that when a site has fast performance, the users are happier, everything is better. So you can't improve on something that you can't measure. And so Google is spending a lot of time and effort on measuring it. So a good site, they basically have three categories: red, yellow, and blue, red, yellow, and green. And they're saying, look, a good site should have green. And so you would think that a lot more sites on the web would actually have green. Turns out, green performance is kind of like a unicorn. It doesn't seem to exist. And so the question you might be asking yourself is like, well, does it actually matter? Like, does it actually matter how long does it take for the website to come on up? And again, Google did a whole bunch of research, talked to a lot of companies, and basically they collected a lot of evidence that says, yes, it matters. And if you think about it, it makes a lot of sense, right? Because you come to a web page, somebody sends you a link, you're on Twitter or something like that, and somebody sends you a link, and it's, the latest and greatest shoes that you absolutely have to have or something like that, I don't know. And then you click on a link and you select, okay, I want to buy this. And you click on the buy button and nothing happens because it is not unheard of for a mobile device on a bad network to have to wait up to 30 seconds before a page becomes interactive. And so in that amount of time, at some point you're like, you know what, I don't really need the shoes that much, and you leave. And so there's a lot of evidence that basically says that for every 100 milliseconds that you can improve your performance of the sites, the conversions get better. More people will purchase. You have more sales. People will view your application as being of higher quality. And yet, you'd think that if there is so much evidence that says that this matters, that we would have a web full of fast applications. But it turns out that is not actually the case. We actually don't have that much. And the question is, well, why? And one way to look at it is the amount of JavaScript that's being sent to the client. And this is from HTTP Archive. You can go visit, and what you see over there is that over time, we're sending more and more JavaScript to the client. And so the question is why? And the short answer is that as users, we expect more and more of our website as time goes on, right? And so while 10 years ago, we were happy with very simple sites that are not very interactive, today, we really want to have our sites to be more interactive, have more features, etc. And so over time, the amount of JavaScript is going up. But it turns out that's the exact opposite thing that you want for a fast website. So when you have a fast website, you want to have as little JavaScript as possible. When you want to have an interactive website, you want to have as much JavaScript as possible. So which one wins? How can we have both? And this is really the question that we're trying to answer. And so there's this trend where the amount of JavaScript that's going to the browser is increasing. And I don't think this is going to stop. I think over time, we will even have more and more JavaScript as we figure out how to make the sites even more interactive. So the interactivity is not here to leave us. It's going to be there forever. So how do we deal with this particular problem? And this is a systemic problem, right? Like, this is not few bad apples, but rather the whole web is having this issue. And so I'm not arguing that we need to write less JavaScript. I think that's futile. You need the JavaScript. We need it. But the problem is not the amount of JavaScript, but how we deliver the JavaScript to the browser. And so the thing that we want to talk about today is figuring out a more intelligent way of delivering all of that to the browser. Now, to convince you that this is an issue, we built this cool tool called Performance Insights. And what the tool does is basically take your site or any site that you want and sends it over to Google PageSpeed Score. They have an API where you can basically say, like, look at this site. And Google then scores your website. In this particular case, this website scored 36 out of 100. And then what we can do is we can perform some optimizations on it. Like, for example, we can resize the images and we send it back to your website, to Google for analysis. And we see the numbers improve. We can optimize the CSS and we see the numbers improve. And we can optimize JavaScript, which is a fancy way of saying we just delete it. And then as you can see, the numbers improve. And so we looked at top 50 e-commerce sites. The numbers are too small to read. You don't have to look at it. Just look at the color. The first column over there is talking about what is the actual performance of these websites today. And what you see is that most of them are red, and yellow is kind of considered good. And so this is kind of a paradigm, right? Like, we have all this evidence that says that it matters, speed matters. And yet, the companies that should care about this the most, the e-commerce companies, the biggest e-commerce companies, the top 50, they actually don't have the high scores. What's going on? And if you go look closely, you actually see that one of the best scores that you can get on this list is actually Amazon. So Amazon understands this need, and Amazon is pushing it as hard as they can, and even they are having troubles hitting the perfect score, right? So something is amiss. And the other thing I want to point out is that as we look at different optimization things, when we optimize images, we get slight improvement in averages, which means for the most part, at least the top biggest e-commerce websites, they're doing a good job on that. If we optimize CSS, same thing. They're doing a good job on that. But if we could somehow delete the JavaScript, we would get a huge increase in performance. So what can we do with JavaScript is really the question. And if you come back to it, you can look at how much JavaScript different frameworks produce. And what you see is that different frameworks have different angles, in different slopes of the line, right? Meaning that the more shallow the line, the more efficient the output of the framework is. And then the intercept at 0 is like the initial code size that the framework has that you see. And you can see that different frameworks have different lines and different initial sizes, but they all are fundamentally the same. Like, if you zoom out far enough, what you see is that they all go up to the right? And so as the websites become larger and larger, which particular technology you choose with the framework seems to not matter that much. And the thing that we need to do is figure out how to have a framework that has a flat slope. So what do we call these particular frameworks are resumable frameworks. And there are companies who have figured this out, and I'll talk to you about it. Like, Google has technology for this, eBay has technology for this, and then Quick is the thing that I'm working on right now. But as you can see in this particular charts, is that unless we can change the way we deliver the code, we're going to be forever stuck in this particular paradigm. And if you extrapolate about what's going to happen in the future, well, you could just assume that line is just going to keep going up forever. And so what we want is we want to break this line, and we want to get this line to 0 in some particular way. And so if you look at how do we get here, I think is important. If you look at the past, what we had is we had server-side rendering technologies like PHP, Ruby on Rails, etc. And we had jQuery on the client. And it turns out doing it that way actually produces very performant websites, because the amount of JavaScript that was on a client was pretty minimal. But it turns out doing it that way is something that we don't enjoy as developers. It was problematic because you essentially had to write the UI twice, once on a server in one language, and then again in the client using another language. And so we have kind of abandoned this particular way of building websites, even though it was very performant. And oh, by the way, this is the way that Amazon is doing it to this very day, because they realize that this is the only way they know how to get performance. And I'm not here to tell you that we should go back to this particular world. That's not what I'm here to talk about. But to just kind of point out that we kind of had a right mental model at some point, but we lost it to the current way of doing it. So you look at the current way of doing it, whether it's Angular, Vue, Svelte, React, or whatever your favorite framework is, It's a component model, meaning you say you have a single language in which you declare how it renders on a server and how it renders on a client. But this particular model has a problem, which is when the person navigates to the website, they basically have a white page for a while until the application executes on the client. And to fix that particular problem, we have different server-side rendering technologies, right? Angular has Universal, React has Next.js, Vue has Nuxt, and all of these technologies are there to kind of show a picture of a website while the framework actually boots up. Now, in the future, I think what we need to solve is a way of doing all this stuff. So have a component model, have a DX system that is actually enjoyable for us to do. So today's DX is excellent. Like, we want to keep that, but at the same time, have a good performance. In other words, some way of getting rid of this hydration. And it turns out there are a bunch of frameworks out there to do this already. So Google has had a framework called Wiz for almost a decade. And it's what runs Google Search. It's what runs Google Photos, Gmail. And one thing you notice about Google Search and Google Photos is that they're amazingly fast, right? It is hard, not that it's hard, I would say it's impossible to navigate to Google Search for something and get to the situation where the page shows some content and you can't click on something. Like, the moment something shows up, you can click on it and you can interact with it, right? eBay is working on a framework called Marco. In version 6, they're going to have a resumability. And of course, there is Quick. So I'm not saying that Quick is going to be the way of the future. What I'm saying is there are frameworks coming that are focusing on this particular problem. And the problem is the amount of JavaScript we're shipping eagerly to the client at the very, very beginning. So there are two properties of these things. One is called resumability. The second one is called progressiveness. So I want to kind of show you the difference. So this is our homepage. Once it's rendered with Quick or resumable framework, and the other side is rendered using a traditional way of doing things. And again, the thing on the right could be rendered with any of this. Could be Wiz, could be eBay for Marco frameworks. I think you would get the same exact result. But what you're going to notice is that the one on the right, the moment the UI shows up, it immediately goes gray. The gray here means that it's finished. JavaScript is done. Whereas the one on the left you're going to see is that it takes many, many seconds before the UI goes gray. And what's happening at that time is basically this fancy term we have for this called hydration. And hydration, if you think about it, is a way for the framework to recover the state of the system so that something useful can happen. And so if we can figure out how to do resumability for our websites, I think we will have a much, much better performance of the system. So what is resumability? I think the best way to think about it is it's like virtual machines. The first time I saw a virtual machine, I was kind of blown away. Because what I saw is that you could, you take a host machine like a Windows machine and you boot up Linux inside of it. And you go through a boot up process, and in a window you can actually see it booting up, and it's kind of weird and exciting. And then you finally get to the login page, you log into the virtual machine. You open up a Word document and you start typing, you start writing a letter, right? And at some point, you can just save the virtual machine. And you get a file, and you can take that file and send it to your friend. And your friend opens the file, and they're exactly where you left off, right? They don't start with the boot up and then get to the login screen and then open the word processor and then type a letter. No. They're literally just in the word processor exactly where you left off. And this instant on resumability is what we need to bring to the web. So it's the same exact thing, except replace file for HTML, and you get yourself resumability. And so what's actually happening is that on a server, you have to render the page, and there's not much you can do that, right? And then once you render it on a server, you can save it in a CDN or something like that. And then the browser has to download the application, so there's a whole download that happens. Then it has to execute the application, and the reason why it needs to execute it is it needs to rerun the templates to figure out where the listeners are. And once it gets the listeners, it can attach the listeners to the DOM. That's called reconciliation. And then once the listeners are attached to the DOM, then the whole thing can run. And so we call these frameworks replayable because if you think about it, the client has to replay what the server did in order to get to the same state. Hopefully it's the same state so that you don't notice anything. And once you go to resumable, the world is very different. You still have to do the same exact thing on a server. That's no different. But on the client, there's nothing to do. You don't have to download all the code and you don't have to execute all the code to figure out what the listeners are because the listeners have been serialized into the HTML and you can just continue where the server left off. So the second part of it is progressiveness, which is if you think about how normal frameworks work, you download all of the JavaScript all at once at the very beginning, but it's not just downloading, it's also executing of it all. So then you execute all the code, and then you're ready to go, right? Now, the problem with that is it takes a long time to download and execute. A progressive framework is one that kind of sips on the problem, right? So it starts very little, and as the user uses the application, more and more code gets downloaded, and more code gets executed. We sometimes talk about it as the difference between streaming and downloading. Imagine you wanted to watch a movie, but before you could watch the movie, you had to fully download it. You know, the experience wouldn't be very good. But that's not how movies work today, right? You stream the movies, meaning that you navigate to a page and you start playing the movie before all of the movie actually shows up at your computer. And then as you're using as you're playing the movie, more and more of it shows up. It's the same exact thing with the framework and with applications, right? The way we need to think about it is how can be in the world where you can stream the application in rather than forcing the full application download all at the beginning. So this is kind of now that I look at it on the big screen, it looks kind of complicated. But the thing I wanted to show here is that the amount of time that the user has to wait for the interactivity is greatly decreased. Because there's two things going on. First of all this code doesn't have to be executed. That's kind of the big arrow over here. This doesn't have to happen. And the second thing is you actually have to download a lot less code to begin with because many parts of the application only really have to run there once, for example, the UI layout, and they never have to download again or never have to re-render again in the client, and so you actually end up downloading less code. So this is kind of the world as I see it right now, is that there's a whole bunch of replayable frameworks, and I see a future where there's going to be a bunch of resumable frameworks. And I think, Marco is, eBay's working on it. I mean, Google has had this technology for a while, which I think is super cool. And of course, then we are working on it as well. The other thing I want to point out is people love performance. And so I'm sure you've seen many benchmarks like this, but these benchmarks kind of miss the point in the sense that they aren't focused on the startup performance, rather they're focused on the actual application performance. And so there's a couple of differences here that I want to point out, which is these benchmarks assume JavaScript is already downloaded. And I think, again, not the case in actually real-world scenarios. They assume that the jitter is already warmed up. And again, I'm going to say that's not the case for initial page download. And they really focus on a DOM update rather than focusing us onto how long does it take before I can click on something. And those are two very different metrics. And so these benchmarks are really focused on performance once everything is loaded. What I really want to talk about is time to interactive or total blocking time, which is how long does it take to actually wake the system up. And so if you look at it from the point of view of how long does it take until the system is ready, you get a very different kind of view. And most importantly, you notice that there are other frameworks who are kind of forcing you to download a lot more code than you would expect. So let's see, I'm going to skip that. So as a joke, we have this thing called the CAP theorem. Have you people heard about CAP theorem in databases? So basically, CAP theorem says that in a database, you can only have one of two things. You can have either consistency or availability, but you can't have partitioned. Or you can have partition and consistency, but you can't have availability, and so on and so forth. And this is generally considered to be true, except Google comes along and installs atomic clocks in their data centers. And through atomic clocks, they can actually break this theorem and can deliver all three things. This is called Spanner, by the way, and I think it's pretty cool. So we are joking that there's something similar in front-end technologies. And so we think there is a front-end CAP theorem where it basically says you can have one of three things. There are frameworks that give you amazing capabilities, frameworks that give you amazing DX, and frameworks that give you amazing startup performance. But it seems like there isn't a framework that can give you all three. So let me give you an example. Angular, React, Svelte, Vue, I think have amazing capabilities and amazing DX. People love using these frameworks, and they're super popular, and there's really no limit to what you can build with them. I think Astro is a perfect example in 11T of frameworks that people love. They have great DX, and they have an amazing startup performance, but there are limits to what you can use these frameworks for, and so you can't have everything you want. And I think there is, Google Wiz has amazing startup performance. Again, every time you use Google Search, you are seeing the performance of the system. And there are no limits to what you can do with the capabilities, but the DX of Wiz, not so much. And so we would like to have a framework which has all three of these capabilities. Basically, have a system that can deliver on all of three all at once. And that's the thing that we're chasing after. All right, my last slide, and then I'm going to give you your time back. So we are at Builder. Builder.io basically does headless visual CMS systems. And we really care about performance of our customers. And so this is the reason we're working on 3 open source cool things. We kind of mentioned Quick, but I want to point out another one called PartyTown. PartyTown is a technology that allows you to take third-party scripts and move them to the web worker. I think the thing is, there is a pattern here, right? And the pattern is, how do you get as much JavaScript as possible off of the main thread, right? That's how you become fast. The main thread should be reserved for the user, and everything else should be somewhere else. And while your first-party code, the code you've written, is definitely a part of the problem, a huge part of the problem is actually third-party code, like Google Analytics, HubSpot, and so on and so forth. And so with PartyTown, you can actually offload that into web worker, and so you can keep your main thread for the user interaction. And finally, we are working on this thing called Mitosis, which allows you to build which allows you to build components for all the frameworks all at once, which is kind of a cool thing. And in this way, you can not just help one, but help everybody in the world. Anyway, so that's us. That's what we're working on. And I really wanted to thank you for your time.